Now we get to have a little bit of fun. Now that we know how polar coordinates work, let's talk about polar equations. So a polar equation works very much like any other equation. In other words, rather than having f of x equals y, what we're going to have is r of theta equals something, right? So like in this case, f of x equals, I don't know, sine of x plus x squared, right? What we're going to have is we're going to have something like r of theta equals, I don't know, let's keep it simple to begin with. Let's talk about r of theta equals sine of theta and have some fun with that. Now, we're going to do a lot of these by hand, but a lot of them are going to be done on our calculators as well. But you have to know how to do these things by hand because it'll make your life easier. This isn't a very long lecture per se. It's just there's some techniques that I want you to pick up. Okay, a lot of it's just memorization, to be honest with you. All right. Okay, so let's see what r of theta equals sine theta equals. Okay, what it looks like. I'm going to graph it over here. So if you look, you know what? I want to make this thing just a little bit bigger though. Let's get it nice and big. All right, and we're going to do it just like we would do any other new type of function. We're going to build a coordinate tree first. Okay, so what I'm going to do is I'm going to instead of like, remember back when we first learned how to do something like this, we would build a coordinate tree that looked like that. And we'd plug in points. Well, we're going to do the same thing, except we're going to do r and we're going to do theta. And we're going to plug in values of theta, just like we plugged in values of x over here, and we're going to get values of r in return. All right, so let's start with 0. If I plug in theta equals 0, then I know that r equals 0. So I've got myself a nice big fat point there that's hard to see, but that's okay. Now, let's just roll through what we know these guys look like. So let's go pi sixth. Right? Let's see, what's the sine of pi 6 again? I think it's root 3 over 2, isn't it? And if I go pi fourths, then I know that r, remember, it's just sine of pi fourths, which is root 2 over 2. And then if I go pi thirds, oh, what am I doing? Pi 6 is 1/2. You guys are supposed to yell at me when I do stupid things like that. All right, so here we go. 1/2, let's see, pi thirds is root 3 over 2. And then let's go pi halves, which we know is 1. And then I'm going to crank through here just a little bit, right? I'm going to keep on going. How about 2 pi thirds? Let's see, the sine of, again, in your brain, you should have all students take calculus. It's also not a bad idea, really, to have your glorious points here, right? What do we have? This is root 3 halves, comma 1/2, and then you get your point root 2 halves, root 2 halves. You know what I mean? I'm just putting these things in as a point of reference. 1/2, comma root 3 over 2, and then 0, comma 1. Excuse me. So let's see, 2 pi thirds. What's that going to be? That's going to be this guy flipped across, so this is going to be root 3 over 2, right? 3 pi fourths is going to be root 2 halves, and then 5 pi 6 is going to be 1/2, and then 2 pi is going to be 0. Or excuse me, 2 pi. Pi is going to be 0, as is 2 pi. All right, now let's see what happens. Let's see what we get here. Because we're going to plot all these. I'm going to plot the other side as well, but I'm not going to plot it per se. I'm going to let the calculator do the heavy lifting. So I ended up with the point, let's call this, since the biggest that sine gets, or that r gets, seems to be 1, I'm going to get a little bit crazy here. I'm going to let's see, 1, 2, 3, 4. I'm going to let this be 1. Because then I can start cutting this stuff up and playing around, okay? So I know I start at 0, 0. I know that if I go out to pi 6, then I'm at 1/2. Since this value right here is 1, I'm just going to go to pi 6. I'm going to cut it in half, so it's going to get me right there. So, whoops. So it's going to get me right there. Now, think about what's going on here. As I get to pi fourths, I get to root 2 over 2, which is about what? 0.7, right? A little less than 0.75. So I'm going to, because root 2 is about 1.4, so I'm going to go, let's see, 1.5, yeah, we'll go out to here. All right, and my drawings are going to be lousy, but that's okay. Let's see. When I get to pi fourths, oh, we already just did that. Pi thirds is root 3 over 2. What's that? What's that going to be? I mean, if I had to, I suppose, if you're just having to check these things, because sometimes, you know, you forget, is it 1.4? Is it 1.57? Is it whatever? There's no shame in checking stuff out. So it's about 1.7, but then I divide it, whoops, I didn't want to do that, but then I divide it by 2, right? So I get pi thirds and 1.7, so what's that going to be, about 0.85? So that's going to get me, I don't know, to about there, right? And then at pi halves, I get to 1. And then, I don't know why that thing's doing that. I get to 1. And then I've just got this symmetric argument right here. True, at pi fourths, or 3 pi fourths, I'm back down in about there. And then at 5, it's doing it again. At 5 pi 6, I get to 1/2. And then back to 0. You guys, what does this look like? It looks like a circle, doesn't it? Of radius 1/2. Now, I'm going to play with that a little bit later, okay? Now, what do you think would happen if I let theta go all the way to 2 pi? Well, let's just go, you know what, I shouldn't have drawn that. I want a little bit more of that table. Let's go just a little bit further. So if I go r and I go theta. So if I let, say, theta go to, well, we should go 1/6 past pi, right? So what's that, 7 pi 6? Well, the sine of 7 pi 6 gets me over here, right? So isn't this going to be negative 1/2? True? Now let's see what that looks like. So 7 pi 6 lives right here. So if I roll over here, this is where I start, but r is negative. So I flip back across. Remember that? So instead of ending up with a point down here, because r is negative, I flip across and I end up right here. Remember, negative r's flip back and forth across the horizontal line, right? Let's do one more. Let's do 7 pi fourths. Well, what's that going to be? 7 pi fourths is going to be negative root 2 over 2. 7 pi fourths is, wait, 7 pi fourths, I'm sorry, 5 pi fourths, right? I'm in the third quadrant here. I'm getting a little ahead of myself. So 5 pi fourths. It's hard to keep all those fourths to straight in your head. So 5 pi fourths gets me to here, and then negative root 2 over 2. Wait a sec, that's going to send me right here. They're coterminal. So really all that I'm doing is I'm retracing this circular path back around. Well, that's pretty cool. Okay, now let's take a look at it on our calculator. All right, you ready? So go to your calculator, go to your mode, and in your calculator, I hope you notice I've got it all set up here. I notice under function, I've got it, instead of under function, which is just regular y equals f of x, I've written it as polar, and then I wrote this as degrees, but since this guy over here is in radians, let's keep everything in radians. Now watch what happens. Whoops, I got to push down. I'm trying to push on the screen. It's not working. Hit enter. And then I'm going to go to y equals. Ooh, hey, look at that. Now let's have a look-see at what goes on here. All right. Ooh, I got to make this. I'm going to scroll back a page. What did we call it? Yeah, it was just r equals sine theta. Okay, so r equals sine of theta. Notice this, it fills it in. Let's go zoom standard and see what the window looks like. Okay, zoom standard and see what, oh, I can't see very much, can I? Let's look at the window. The window goes from 0 to 2, or yeah, it looks like 0 to 2 pi, right? 6.28 is twice 3.14. My theta step's pretty small. That's always a good thing. I don't like this min-max thing. So I'm going to go to my window here. I'm going to go to window, and I'm going to tweak this. What do we say? It didn't appear to be a circle of, I don't need to be way out to 10. In fact, the highest that I get is 1. So maybe the x-min can be -2. We'll go -2 to 2, and then we'll do the same thing. We'll go -2 to 2. We'll keep it uniform. And then let's graph it and see what it looks like. Hey, look at that. I mean, it's ugly, but that's because of the step. If I wanted to make it a little prettier, I could actually go down to my step and go to, say, 0.05. Let's go, or 0.05. Let's graph that. It's going to take a little bit longer. Look at that. That's kind of cool, huh? That's neat. Now look, I can also do my trace, right? So if I plug in a theta and I go, I don't know, if I want to go pi fourths, and hit enter, notice what it gives me. Pi fourths, theta equals 0.78. XY, ooh, that's weird. Look at that, it gives me an X value and a Y value, doesn't it? That's crazy. That's really, really cool. Let's see what our table looks like. Take a gander at that. Whoa, look at that. That's awesome. That's really cool. Let me show you. I think over here in my view, I can watch this, I think. Yeah, look at that. That's kind of groovy. I think I've showed you this stuff before. So these are my thetas. If I toggle down, I can toggle through some other stuff, right? These are new thetas. All right, so you got all kinds of tools that you can use. They're at your disposal. Now let's play some more. Let's do one more and see what happens. Oh wait, before we do, I think this is actually worth seeing. Let me shrink this thing down. Let's go to view. I'm gonna hide my view. Okay, and might as well let's hide our key history as well, because this is really all that we need right here. Let's go a little big. Let's go a little big. Let's prove that this is a circle, just for giggles, okay? Now, watch. I know that r equals sine theta. If I wanted to, couldn't I multiply both sides by r? And you may say, well, Ripley, why are you multiplying both sides by r? What are you doing? Well, because, I don't know, I remember with polars, if I multiply both sides by r, I get r squared equals r sine of theta, right? And r squared is x squared plus y squared, and r sine of theta is equal to y, right? So if I go x, I'm going to need some more room. This may end up carrying over this way. X squared plus y squared minus y equals 0. If I do a little completion of the square a la algebra 2, won't I end up with, let's see, x squared plus, if I go half the b term and square it, that's going to be a fourth. So I'm going to get y squared minus y plus 1/4 is equal to 1/4, which implies that I get x squared plus y minus 1/2 squared equals 1/2. Well, what's the center of this circle? Well, the x is 0 and the y is 1/2. So the x is 0. Hey, well, hush my mouth. Well, what's the radius? Right? What's the radius of this thing going to be? Well, wait, where did I get? This should have been a fourth, sorry. Yeah, I got crazy with the half. I got ahead of myself. Well, remember, this is r squared, which implies that the radius is 1/2, which, of course, is exactly what it is. Yeah, isn't that awesome? That's fun stuff. Now, I am not going to force you through those coordinate trees over and over and over again, all right? You'll hate me for it, and quite frankly, I couldn't live with myself. However, let's see if we can play. And I'm going to give you some new stuff to work with that will reduce the amount of coordinate tree garbage that you have to do. How about this? How about r equals 2 plus cosine of theta?